This is a sample of the information provided as part of the flexible training resources available through HACCP.com. Our training courses are designed to provide training participants with an understanding of food safety and quality system elements and also offer user-friendly assessment activities and competency checklists to complete the training cycle. HACCP, Physical Hazards Management. Key definitions for HACCP, Physical Hazards Management. Biological hazard, the danger posed to food safety by the contamination of food with pathogenic microorganisms such as viruses, bacteria, spores, fungi or naturally occurring toxins. Chemical hazard, the danger posed to food safety by the contamination of food by chemical substances, such as pesticides, detergents, additives, and toxic metals. Electrons, the electron is a subatomic particle that carries a negative electric charge. It has no known components or substructure, and therefore is believed to be an elementary particle. Hazard Analysis Critical Control Point or HACCP. HACCP is a food safety methodology that relies on the identification of critical control points in all stages of food business processes. Macrobiological, large living organisms. Microbiological, organisms that are usually too small to be seen with the naked eye including protozoa, bacteria, fungi, and viruses. Photodiode. A photodiode is a type of photodetector capable of converting light into either current or voltage, depending upon the mode of operation. Physical hazard, particles or fragments of items not supposed to be in foods. X-ray, to take an X-ray of something using X-radiation composed of X-rays, which are a form of electromagnetic radiation. HACCP, Physical Hazards Management Development. When considering the development, documentation and implementation of HACCP, Physical Hazards Management within food safety and quality management systems, the following information should be considered to ensure effective outcomes. About HACCP, Physical Hazards Management. Physical Hazard Policies. Physical Hazard Identification and Control Methods. What types of metals can be detected? Controlling foreign materials. About HACCP, Physical Hazards Management. When considering the hazards associated with the process steps in the HACCP plans, the three traditional groupings of hazards to consider include biological, chemical and physical hazards. As HACCP plans evolve and customer standards and regulatory requirements become more stringent, often allergens, regulatory hazards, quality hazards and engineering hazards are also commonly considered in HACCP plans. Physical hazards, as with chemical and biological hazards, are able to enter a food product at any stage during its processing. As you can imagine, there are limitless numbers of physical items that can enter food as foreign objects, some of which can also be classed as macrobiological, but very few of these pose a real food safety risk. For example, a customer may find a hair in their food undesirable, however, it is most unlikely to harm them. Such foreign objects need to be assessed as to their status and potential to be classified as either food safety hazards or quality hazards. Subsequently, any physical hazard has the potential to be a food safety hazard should the item in question cause the consumer to choke. It is worthwhile to note here that a food business could be prosecuted regardless of whether the item is a genuine food safety hazard or not, simply because the product received by the customer was not of the true composure as demanded expected by the consumer. It should also be taken into account here that as mentioned previously regarding macrobiological hazards, foreign items have the potential to transport microbiological hazards into a food product. The food product's intrinsic ability to be safe relies on the processing status and whether or not the product will undergo further control measure after the introduction of the physical object. Good manufacturing practices should ensure that physical hazards are controlled within the food production environment. Examples of physical hazards that are of concern regarding foods include glass, metal, stones, wood, plastic, pests. Glass. Glass fragments can cause cuts to a consumer's mouth, and could potentially have very serious health consequences if swallowed. Smooth pieces of larger glass have the ability to cause injury through choking, or could be broken into smaller, sharper pieces when the consumer bites into the food. Glass can be present in raw materials, generally as foreign matter from the growing or processing site, or maybe from the container in which the raw materials are, or have been stored. Glass containers for storage and handling should be eliminated wherever possible in food processing areas. In addition, staff should limit the amount of glass on their person while contacting foods, and equipment should use specified safety glass where needed, in lieu of substitutions. Glass light fittings should always be covered appropriately to reduce the risk of contamination should the light bulb shatter. It is quite often difficult to totally remove glass from food contact areas, especially where glass is being used as packaging, or for food service. Food safety systems should identify where throughout food production glass is a potential hazard, so that it may be managed correctly, with the use of stringent breakage control procedures in place. Metal. Like glass, metal can enter food products at all stages, and is of concern because of its ability to cause injury at sharp pieces, or choking. Equipment maintenance is particularly important within this issue, effectively reducing the risk of machine parts, filings or the like from accessing foods. The process of maintaining the equipment also becomes cause for concern, as it is possible for equipment parts to enter foods during servicing. Where raw materials are delivered in metal containers, great care should be taken not to introduce swarf or metal shavings into the food processing environment. Stones. Stones are more than likely to originate from sources of plant origin, where they are transported into production within the plant either within fruits, vegetables or plants, or on the extremities of these from a harvesting process. Stones are hazards as they can cause dental damage or choking, and sharper stones may cause problems similar to those of glass and metal. The presence of stones within foods can be prevented through careful handling and preparation procedures, and by the use of equipment such as centrifuges and flotation tanks for food items. Wood. Wood can cause cutting and choking, as with other sharp objects. Wood may be present in raw materials from its primary production, or may be introduced into production through other means. Wooden packaging and raw materials should be handled with care so as not to cause splintering where food contact may occur. Some traditional products may contain wood as part of their production, for example, some Japanese fish cake products that are cooked on wooden slabs. Such products should be handled with caution so as not to be the cause of a food hazard. Wooden equipment has in most cases been superseded in its viable commercial food production presence. Plastic. Plastic is quite often used in replacing glass and wood objects, in an effort to reduce hazard risks, where quite often it itself becomes a hazard. Hard plastic can cause serious injury, almost as severe as glass, and breakages should be treated as for glass. Soft plastics are used for packaging, as well as protective clothing such as gloves and aprons, and are usually monitored via visual inspection, their vibrant colors making them more readily identified. Hard and brittle plastics are commonly classed within glass policies, to ensure their appropriate and effective control. Pests. Along with their risk as biological hazards, pests also pose a threat as choking hazards in foods. Of most concern in this regard are large insects and parts of rodents or birds. An effective pest control regime will eliminate the risks of such pests entering the food production process, and should be part of the good manufacturing practices as expressed in the food safety system. Foreign object outcomes. Foreign materials of significance can be defined as to their ability to cause a potential choking hazard for consumers, potential damage to teeth or internal organs, potential allergy threat as particulates or general content. Physical hazard policies. Policies are often formatted regarding the scope and purpose of policies for all categories of physical hazards relevant to any particular food business. Potential hazard policies may include which physical hazards are of particular concern, areas in which the control of physical hazards is relevant, procedures regarding the control of relevant physical hazards, including strategies for corrective actions, the use of a register for physical hazards which are required and used in high-risk areas. This may include nominations for items such as glass light bulbs and wooden pallets, which may be unavoidable regarding use. Physical hazard identification and control methods. There are numerous different and varied methods through which physical hazards can be identified and controlled within food businesses, including, but not limited to, screening. Inline screens are useful for the removal of foreign objects during food processing. A relevant sized screen, or series of screens, may be placed in line to capture any foreign matter as the product passes through it. Screening is useful for manufacturers of liquids, powders, and free-flowing granulated products such as coffee beans or grains. Magnets. Inline magnets are commonly used within dry and liquid food and ingredient industry sectors. Where product is air-blown or vacuum pumped around its processing to circuit, inline magnets may be used to capture metal fragments. Often a series of magnets are used since not all of the product moves over the surface of every magnet. Regular removal of the magnets and cleaning of them is imperative for the magnet to work to its maximum capability. It is also important to consider that magnets may lose their strength over time, so they should be calibrated on a regular scheduled ongoing basis. Metal detection. Advances in technology and its availability to food businesses have ensured that metal detection is a standard hazard control method within many differing international food industry sectors. The reasoning for including metal detection within a food processing and/or packaging environment include product safety, equipment protection, contract or customer requirements, and regulatory compliance. The use of metal detectors will never guarantee a metal-free food product, but a properly designed, installed and maintained unit, along with a metal contamination control program, can be extremely effective in identifying and controlling related hazards. Metal detectors are an important part of any comprehensive physical hazard control program. If metal detection units have been specified, installed, operated and maintained correctly, they will contribute to improving product quality and reducing operational losses. Did you know that HACCP.com includes resources that allow you to create, manage and implement GFSI and HACCP-based food safety and quality programs? Improve your food safety and quality skills and knowledge? Train and develop your team to create better food safety and quality outcomes? Find suppliers and service providers to partner with your business? The information and training resources available through HACCP.com included a variety of formats, such as website content, MP4, MP4 and text, MP3, PDF and slideshow. Are you ready to take the next step in your food compliance journey? Visit HACCP.com today to create your profile and access the full versions of our food safety and quality information packages and much more.